On this Grasshopper tutorial, we want to talk about creating a sine motion on a mesh. So let's talk about the algorithm. As you can see, we've got a mesh here, and each mesh is made of some vertices. And there is a normal vector for each vertex. What we're going to do here is to move vertices along their normal vectors. So we drop a point outside of the mesh in case to measure the distance between each vertex and the point. We use this equation to move vertices along the normal vector. After we got their distances, we can use them as a factor in this equation to create the motion along the normal vector. Let's start the definition by bringing mesh-sphere component and extract their vertices by using the construct mesh component. As I said before, we need to create a sine equation, and we do this with evaluate component. Let's change the name of variables. Change x to t as time variable, and change y to dist as distance variable. Double-click on it to write the equation. Sine dist plus t. Hit OK to confirm the equation. Let's drop a point somewhere, then bring distance component to measure the distance between the point and our vertices. Connect the distance to our equation variable. We want to use the equation result as length of our normal vectors, so let's bring amplitude component to do this. We connect our normals to vector input and equation result to amplitude input. Move vertices along our vectors by move component. Connect vertices to geometry input and our vectors to translation input. To create a new mesh from these vertices, I'm going to bring construct mesh component and use our new vertices, and also use base mesh faces to make our new mesh. As you can see, we create this wavy shape motion, and we can change the wave pattern by changing the point position. Because the distance between the point and our vertices is one of our parameters in the sine equation, but we also need to animate this shape as well. In order to do it, we have to create a counter to add a number constantly to it. To create a counter, also known as engine in Grasshopper, what we need is timer, record, and mass addition components. Connect data record to mass addition and connect timer to data record. Now we need a number which describes how fast it changed through our time interval. So to be clear, timer component interval represents how smooth is our motion, and the number describes how fast our shape changed through time.